it is equal to tau max is equal to square root stress yield squared minus by stress average squared divided by 3. Okay. So they are not the same. Okay. So just something to take note, right? So you can see the difference in the expression. So the thing that is common between Tresca and Vomisis criteria are mass mole circle during analysis. Okay. So in your exam, 3D mole circle will be involved, but in order to do 3D mole circle, you need to do what? 2D mole circle. Okay, and I have confidence that you all are expert in mole circle now. Okay, so that's the common thing. Okay, so could you imagine now seeing a problem like this, right? Remember, you have to able to, so a problem like this, you need to calculate the stresses on the element, right? Then after calculating stresses on the element, you have to plot 3D mole circle. After plotting 3D mole circle, then you need to apply U criteria. Okay. And all these are based on combined loading. So in your final exam, 4 different topics, 1 question. You will have a question something like this. I promise you. I already said it already. Okay. And this question is really, really important because when you do 3EO3, all questions are like that. Are we clear? All questions are going to be like that. Okay. Right. So we are now going to focus on the Tresca criteria now. Okay, Tresca criteria. So in Tresca criteria, we know that stress max is equal to stress yield divided by 2. Okay. And a big thing that they assume, okay, is that Tresca assume that the yield strength is the same as compression. Okay. So when you assume something, what does it mean? Making an S out of you and me. Assume, right? Unfortunately. Okay. So, however, we know that in real life, right, stress yield in tension is usually smaller than stress yield in compression. We know that. So with this expression, stress yield, right, is a what? Is a material property. So now I'm going to take from the textbook, right? If we look at the textbook, where is my textbook? If we look into a textbook, okay, and then when we go down, okay, we see properties like this. Now, when you see properties like this, right, you know how it's measured, yes or no, right? You have the confidence, right? So if we were to take out, if I'm going to copy a section from here, right? And we have a table like this. And what you see, and it's very common, okay? What you see is if we look at the yield strength, now we don't look at ultimate strength. Any idea why? It's because of what? In ductile material, right? You don't want your structure to go into plastic deformation, yes or no? That's why we focus on the yield strength. But what can you see about the yield strength? Most of the tests are done in what? Are done in tension. Very seldom any of these tests are done in what? Are done in shear. Because tensile tests are easy to carry out, have lower in what? Are lower in cost, right? So what if you want to design something based on this material, which is a ASTM A992 grade 345 in terms of shear? Is the shear value given? No, right? So you can assume using Tresca criteria that the maximum stress will be equal to the normal stress yield divided by 2. So when that is the case, you will have 345 times 10 to the power 6 divided by 2. Is equal to 17172.5 times 10 to the power 6 Pascal. Okay. If we were to look at ASTM, I know it's given, okay, A36, right? We know that the tau max will be equal to the stress yield, which is 250 divided by 2, which is equal to 125 times 10 to the power 6 Pascal. But given to us is 145 times 10 to the power 6 Pascal, and this has been determined experimentally. If you don't have the value, you will take 6 months to do a test because welcome to Canada, we're not really fast. Or you just divide by 2 because you're from McMaster. Just divide by 2. We realize that we are more conservative. It's okay. At least better than waiting for 6 months. We clear. Okay. However, you have to highlight that assumption. Okay? If you don't highlight the assumption, there's something wrong. Okay, we can't do things like this. Okay. So now, let's now sketch 3D mold circle. Okay, sketch 3D mold circle and see how Tresca criteria works. Okay, so we are going to do based on three-D mole circle. Okay. And structure analysis. We know that tau max is equal to stress max divided by 2. Okay. And we also, for this case, stress mean is going to be equal to 0. Okay. I'm going to call this equation number 1. Okay. So by looking at equation number 1, so equation number 1, okay, is when one of the principal stresses is at stress mean is equal to 0, and the other two principal stresses are either both positive or both negative. Okay. So now I start by sketching an element this is our element, and you know now what is our in plane and what is our out of plane. You will be very good in this now. So we are going to assume stress X is positive, stress Y is positive, and then we have positive shear. And I'm going to write this out based on this condition. Stress X is greater than stress Y. Okay. Shear XY is equal to shear YX, and they are both positive shear. Given that stress Z is equal to 0, okay, and furthermore, stress shear XZ is equal to shear ZX is equal to 0, and another condition is shear YZ is equal to shear ZY. They are all equal to 0. Okay. So we start labeling this. This is our point X. This is our point Y on mole circle. And over here, this is our point Z. So now we are going to construct 3D mole circle. I'm so glad you all know mole circle. Okay. So we're going to sketch. Students will ask me, is the final exam accumulative? What do you think? Yeah. What can I tell you? Okay. Final exam is a lot on integration of different theory. Okay. So we know that this is our normal stress. Shearing stress, element rotate clockwise, element rotate anti-clockwise. Okay. So what we know that over here, this is our point what? Our point Z. Okay. Then I'm going to sketch that this is our point X. And then we have our y